The hidden force that sustains the universe. The mystery of the cosmological constant. There is a concept that Albert Einstein once called the biggest mistake of his life. Yet today, it is considered one of the key factors determining the fate of our universe. This concept is known as the cosmological constant. It drives the expansion of the universe, pushes galaxies apart, and defines the fundamental laws of existence. But what exactly is the cosmological constant, and how does it maintain the stability of the universe? Let's explore its secrets together. What is the cosmological constant? The cosmological constant, lambda, was first introduced by Albert Einstein when he extended his general theory of relativity. At the time, he believed the universe was static, so he added this term to counteract gravity and maintain equilibrium. However, in 1929, Edwin Hubble discovered that the universe was expanding. This revelation rendered the cosmological constant seemingly unnecessary, leading Einstein to dismiss it as his greatest blunder. However, modern cosmology has brought this concept back into the spotlight. In 1998, observations of distant supernovae revealed that the expansion of the universe is not only continuing but accelerating. Scientists realized that the cosmological constant might actually be responsible for this accelerated expansion. In other words, it is not just a mathematical trick but a real physical force that governs the universe. How does it maintain the stability of the universe? The universe is governed by a delicate balance between gravitational attraction and a mysterious repulsive force. Gravity pulls matter together, forming stars, planets, and galaxies. In contrast, the cosmological constant acts like an anti-gravity force, accelerating the expansion of the universe. Imagine a balloon being inflated. The more air you blow in, the larger it grows. In this analogy, the cosmological constant functions like the force inflating the balloon, driving the universe's expansion. If the cosmological constant were too large, the universe would expand so rapidly that galaxies and stars could never form. If it were too small, gravity would dominate, causing the universe to collapse. The fact that our universe exists in a stable state suggests that the cosmological constant has just the right value to sustain its structure. The link between the cosmological constant and dark energy. Today, the cosmological constant is closely associated with the concept of dark energy, the mysterious force that makes up approximately 68% of the universe and is responsible for its accelerating expansion. Current research suggests that the cosmological constant might be a manifestation of dark energy. However, there is still debate over whether dark energy is truly a constant or if it evolves over time. Some scientists propose a dynamic form of energy, known as quintessence, which changes as the universe expands. If this is the case, the cosmological constant may not be constant at all but rather a fluctuating force influencing the universe's fate. Determining the fate of the universe, the cosmological constant is not just a factor in explaining the current state of the universe. It also determines its ultimate fate. 1. Big Crunch. If the cosmological constant were zero or very small, gravity would eventually slow down the expansion and cause the universe to collapse back into a singularity. 2. Big Freeze. The most widely accepted scenario today. 2. If the cosmological constant remains constant, the universe will continue to expand indefinitely. 2. Over time, galaxies will drift apart, stars will burn out, and the universe will become a cold, dark, and lifeless void. 3. Big Rip. If the cosmological constant increases over time, it could eventually become so strong that it tears apart galaxies, stars, planets, and even atomic structures, leading to a catastrophic, Big Rip. While the exact fate of the universe is still uncertain, current evidence suggests that the Big Freeze scenario is the most likely outcome. The hidden order of the universe, the cosmological constant, is not just an abstract mathematical term. It is a fundamental force that shapes the destiny of our universe. Although Einstein once dismissed it as a mistake, we now recognize it as a key factor in explaining the accelerating expansion of the cosmos. Moreover, its connection to dark energy remains one of the most profound mysteries in modern physics. The universe operates under laws far more complex and mysterious than we can perceive. The cosmological constant may be the invisible force holding it all together. Will we ever fully unravel this cosmic mystery? Or will the universe continue to pose new questions for us? The answers await in the future of scientific exploration.